Okay, so for number 9, we said u equals ln y and v prime equals y, because we know the derivative of ln y, which is 1 over y, and v equals, that makes v equal y squared over 2. Okay, so by using the integration by parts, we say this whole thing equals to ln y times y squared over 2 minus integral um, u prime. Okay, 1 over y times y squared over 2 dy, which equals y over 2 dy. And we can pull that 1/2 out of the integral, so that makes y integral of y dy, half integral of y dy, and then that equals y squared over 2 plus c. Okay, 11. Oops. Q to the 5 ln 5q dq. So u and then v prime. U equals ln 5. So v prime equals q to the 5. That makes v q to the 6 over 6, and u prime 1 over 5. No, wait. Oh, 1 over 5q times 5. Okay, so we have to use the integration by parts, which is ln 5q times q to the 6 over 6 minus integral of ln of 1 over q times v, which is q to the 6 over 6 times dq, which is, so we pull that 1/6 out of the way, so that this whole thing equals ln 5q times q to the 6 over 6 minus 1/6 times q to the 6 over 6 plus c. Okay, which is alright, 13. Integral of sine squared theta d theta. Okay, so we can write this as integral of sine theta times sine theta d theta. So u equals sine theta, v prime equals sine theta, u prime equals cosine theta, and then v equals negative cosine theta. Okay, so we write this by using integration by parts. uv minus integral of u prime v dx. Okay, so uv is sine theta times negative cosine theta minus integral of u prime, which is cosine theta, times v, which is negative cosine theta d theta. So we write this. And for this part, we use the integration by parts again. Hold on, do we? Okay. So this whole chunk goes into this parenthesis. This case, u equals cosine theta. We'll pull the negative out of the way. V prime equals cosine theta. V equals sine theta. U prime equals negative sine theta. So uv, which is cosine theta sine theta minus u prime v. Okay. For this one, we can notice that this thing, which we are trying to find ultimately, and this thing are the same. So wait, did I do this right? Hmm. Okay,